Look at Earth. It's the only home we've ever known, but is it still sustainable? Is it still enough? If we're being honest, the picture isn't pretty. We're facing a crisis of unprecedented scale: climate change, pollution, overpopulation. And while we've seen the impacts of these problems for decades, the situation is growing more urgent by the day. More than ever, we're realizing that Earth's resources aren't infinite. We've pushed our planet to its limits. Oceans are rising, forests are disappearing, and the air we breathe is filled with toxic chemicals. You can feel it. Our home is changing, and not for the better. And if things continue down this path, the Earth we know today may no longer be able to support life as we know it. Scientists have been sounding the alarm for years. Researchers are monitoring everything from ice caps melting to species disappearing, and their predictions aren't exactly encouraging. In fact, many of them believe humanity could face a tipping point where no amount of change can reverse the damage we've done. So what does the future hold? Do we accept the consequences of our actions and live with the fallout? Or do we take a bold step forward seeking new solutions? Is there a way to save humanity from the brink of collapse? Here's the wild idea. What if Earth isn't our only hope? What if the key to humanity's future lies not in fixing what's broken here, but in creating something entirely new? Imagine this: a new world, a new Earth. Not just a place to survive, but a place to thrive. A place where humanity could rebuild, start fresh, and maybe, just maybe, get it right this time. That's the hope that drives a new generation of scientists, visionaries, and engineers. A dream of terraforming, transforming other planets, moons, or even asteroids into new homes for humanity. And the most ambitious of these dreams? Creating a new Earth. Terraforming is a bold, almost impossible concept, altering the environment of a barren world to make it capable of sustaining human life. Imagine turning a planet like Mars, or a moon like Europa, into a livable space, complete with breathable air, water, and fertile soil. Technologies we once thought were decades away are now at the forefront of human innovation. From atmospheric processors that can create breathable air to advanced systems that regulate temperature, we're getting closer every day to making terraforming a reality. And it's not just about saving ourselves, it's about creating a future for the next generations, giving humanity a second chance on a new world. So why terraform? Why create a new Earth? Because we can't wait for Earth to heal itself. Because the cost of inaction is too high. The clock is ticking. And in 2125, it's not just about surviving the challenges we face today. It's about ensuring that humanity has a future tomorrow. A future where we don't just exist on the edge of collapse, but where we flourish. Terraforming a new Earth could be the ultimate solution to our planet's fragility. But the journey to this new world is far from easy. It will take courage, technology, and above all, a collective will to imagine and build the future. Let's take a step back. What exactly is terraforming? We've talked about the need for a new world, but what does it really mean to terraform a planet? Simply put, terraforming is the process of making a planet, moon, or other celestial body habitable for humans. It's about transforming environments, turning barren landscapes into places where life can thrive. Imagine you're standing on a cold, lifeless planet. The air is thin, the ground is barren, and there's no sign of water. Now picture that same planet after centuries of work. Oceans filling the valleys, plants taking root, an atmosphere thick enough to breathe. That's terraforming in action. So how do we go from this to this? Well, it all starts with understanding what makes a planet like Earth so special. Earth is unique in that it has just the right mix of elements to support life. An atmosphere that provides oxygen, a magnetic field to shield us from solar radiation, liquid water, and a stable climate. These elements didn't just appear out of nowhere, they were the result of billions of years of natural processes. The challenge with terraforming is we're not waiting billions of years for nature to work its magic. We need to make it happen, fast. Take Mars, for example. It's a prime candidate for terraforming because it's close to Earth in size and composition. But Mars has a major problem: its atmosphere. It's mostly carbon dioxide with hardly any oxygen, and it's too thin to trap heat. Without the right atmosphere, Mars can't support life as we know it. To fix this, we need to thicken the atmosphere. Scientists have proposed methods like releasing greenhouse gases into the air to trap heat and raise temperatures. This would help create a more Earth-like environment where water could exist in liquid form. Now, Venus. It's the complete opposite. It's got a thick, toxic atmosphere made mostly of carbon dioxide and surface temperatures that can melt lead. Not exactly a place you'd want to call home. The idea of terraforming Venus might sound impossible right now, but with the right technology, it's not out of the question. Imagine deploying solar shields in space to reflect sunlight, or creating machines to capture and store carbon dioxide. Over centuries, these processes could cool Venus down to temperatures where liquid water could exist. And who knows? Maybe one day people could walk on its surface. But it's not just planets like Mars and Venus that could become habitable. What about the moons of Jupiter and Saturn? Take Europa and Titan. These icy moons are full of water, hidden beneath layers of ice. The challenge here isn't about creating an atmosphere like we would on Mars, but warming up the surface and making it accessible for humans to live. Europa, for instance, might seem like a frozen wasteland, but beneath its ice, scientists believe there could be a vast ocean. With the right technology, we could drill down to access that water, and maybe even warm the surface enough to create habitable environments. It's like creating a pocket of life within a frozen moon. So what's the process of terraforming? It's not just one simple step. It's a series of complex, interconnected tasks. First, we need to make sure the atmosphere is breathable, with the right gases to support human life. Then, we need to regulate temperature, keeping it just right for life to flourish. Finally, we need water, which is essential for everything from drinking to growing food. Now that may sound like a huge challenge, but there's a reason we're taking this seriously. Over the last century, we've made incredible strides in technology. We've sent missions to the moon, to Mars, to the outer reaches of our solar system. And the tools and knowledge we've gained from these expeditions are key to making terraforming a reality. Terraforming isn't just a science fiction fantasy anymore. It's a challenge we're actively working on. And while we're still in the early stages, the groundwork has been laid. Over the next century, the goal isn't just to reach Mars, it's to transform it and other worlds into new homes for humanity. Once we understand the science behind terraforming, it becomes clear that it's not just about surviving. It's about thriving in a universe that's full of possibilities. We've learned a lot from Earth, and now we have a chance to apply that knowledge to new worlds. Now that we know what terraforming is and why we need it, let's talk about the most exciting part, the technology. In 2125, we're not just dreaming about terraforming, we're doing it. But it's not as simple as flipping a switch. It takes cutting-edge technology, decades of research, and a whole lot of innovation to transform a barren planet into a thriving ecosystem. So, what tools are we using to make it all happen? Let's start with the basics. One of the most critical aspects of terraforming is controlling the temperature of a planet. And when we talk about temperature regulation, we're talking about some seriously advanced tech. On Mars, for example, we use giant solar mirrors placed in orbit. These mirrors reflect sunlight onto the planet, warming it up and slowly releasing the frozen carbon dioxide in the atmosphere. This process helps create a greenhouse effect, which is essential to creating a more Earth-like atmosphere. Enter atmospheric processors, machines designed to pump out the right gases into the air. These massive factories work like supersized air purifiers, capturing excess carbon dioxide and releasing oxygen. They also help create nitrogen-rich air, which is necessary for sustaining plant life. These systems are powered by solar and nuclear energy, and they're designed to run for decades, slowly transforming a world from unbreathable to breathable. Once the atmosphere is on its way to being habitable, it's time to think about ecosystems. It's not enough just to have air and heat, you also need the building blocks for life. That means soil, water, and plants. To create soil, we use engineered microbes, tiny organisms that break down minerals and other materials to form fertile ground. These microbes are critical because they can jumpstart the process of creating soil on a planet that has none. These microbes can be specially designed to work in extreme environments. For instance, they can thrive in the harsh, dry conditions of Mars or the toxic atmosphere of Venus, converting minerals into nutrients for plants. Once the soil is ready, it's time to introduce the next key player: plants. On Earth, plants are nature's air filters. They absorb carbon dioxide and release oxygen, which is exactly what we need on a terraformed world. But these plants need the right conditions to grow, things like the right temperature, water, and light. So, to get plants growing, we rely on controlled environments like massive greenhouses, built to simulate Earth's ecosystem. In 2125, we have autonomous robots that can plant and maintain these greenhouses. They monitor humidity, temperature, and soil quality, making sure that plants get everything they need to thrive. And these plants, they're not just about looking nice, they're part of a bigger mission. They help create a stable ecosystem by absorbing carbon and producing oxygen, slowly bringing life to a barren planet. Of course, you can't have a healthy ecosystem without water. On a planet like Mars, where water is locked in the ice, we need to get it moving. One way to do this is by using water vapor generators, machines that release moisture into the atmosphere. These systems collect water from ice deposits, and through a process called sublimation, they turn it into vapor. Over time, this vapor cools, forming clouds and eventually precipitation, which can help create rivers, lakes, and oceans. Another huge part of terraforming is energy. Every one of these machines, from atmospheric processors to greenhouses and water vapor generators, needs an enormous amount of energy. Thankfully, by 2125, nuclear fusion is no longer just theoretical. Fusion power plants provide almost limitless, clean energy, which is perfect for fueling the vast terraforming operations happening on distant worlds. While all of this technology is crucial, it's the people who are driving this transformation forward. In 2125, humanity is united in the pursuit of terraforming. Space stations, research labs, and colony ships work together to make these projects a reality. Astronauts and scientists are not just studying the planets, they're shaping them, turning science fiction into science fact. And it doesn't stop here. In 2125, we're constantly innovating. New technologies are being developed every day to make the process more efficient, faster, and sustainable. From AI-powered drones to advanced materials that can withstand extreme conditions, each breakthrough brings us one step closer to turning distant planets into thriving worlds. With all this advanced technology, the dream of creating new Earths is no longer a distant fantasy. The tools are in our hands, and humanity is beginning to rewrite the future of space colonization. Alright, let's take a moment to really think about what we're up against here. Terraforming sounds incredible, right? Turning a lifeless world into a new Earth, creating lush forests, oceans, and skies full of breathable air. But here's the thing. It's not as simple as flicking a switch. In fact, the challenges of terraforming a planet are almost as vast as the universe itself. Let's start with Mars, our closest candidate. It's cold, with temperatures dropping to minus 100 degrees Celsius at night. Its atmosphere is thin, made mostly of carbon dioxide, far from what we need to breathe. And the pressure? It's so low that without a spacesuit you'd be dead in minutes. Not exactly the type of place you'd want to build a home. Even with all our advanced tech, turning Mars into a livable planet won't be easy. One of the biggest obstacles is that Mars doesn't have a magnetic field. On Earth, our magnetic field shields us from solar winds, those constant streams of charged particles from the sun that could strip away our atmosphere over time. Without a magnetic field, Mars has already lost much of its original atmosphere, which makes it even harder to rebuild. And then there's the dust. Mars is covered in fine red dust, which gets blown around by intense winds and dust storms. These storms are not only a nuisance, but they're also a problem for solar power, one of the main energy sources we'd rely on for terraforming. Imagine trying to keep a solar panel running when it's covered in dust. And then there's the dust. Mars is covered in fine red dust, which gets blown around by intense winds and dust storms. These storms are not only a nuisance, but they're also a problem for solar power, one of the main energy sources we'd rely on for terraforming. Imagine trying to keep a solar panel running when it's covered in dust every other day. But it's not just the technical stuff that's challenging, it's the sheer scale of the task. We're talking about transforming an entire planet, no small feat. When we think about the timescales involved, decades, centuries, maybe even millennia, it's almost mind-boggling. A single human lifetime might only scratch the surface of the changes needed. Imagine the scale of these operations. You're not just setting up a few machines here and there. To terraform a planet, we need to work on every aspect of it: atmosphere, temperature, water cycles, ecosystems, and all of this needs to be coordinated across vast distances, with the latest tech supporting teams working on the ground and in space. It's like planning the largest engineering project humanity has ever attempted. And the reality is, we don't fully know all the answers yet. We don't even know what the long-term effects will be. What happens when you introduce an entire ecosystem into a place that hasn't had one for billions of years? Will it be enough to sustain life? Or will we cause irreversible damage to the very planet we're trying to save? Even with the best plans and the most advanced technology, terraforming is like walking a tightrope. One misstep, and we could make things worse instead of better. For example, releasing too much carbon dioxide into the atmosphere could lead to runaway warming, a scenario known as a runaway greenhouse effect, where the planet gets too hot to support life. It's a delicate balance. Now, take Venus, arguably one of the most challenging planets to terraform. With surface temperatures hot enough to melt lead, and an atmosphere thick with sulfuric acid and carbon dioxide, the idea of making Venus habitable seems almost impossible. But with the right tech, it might still be possible. But it's going to take extreme efforts, like removing huge amounts of carbon dioxide and cooling the entire planet. However, removing carbon dioxide from Venus's atmosphere isn't as simple as just sucking it up. The planet's gravity and atmosphere are so dense, it would take enormous amounts of energy and effort to even make a dent. Plus, Venus's extreme heat makes it a challenge for any machines or habitats to survive. There's no doubt that the process will take generations, if not centuries. And let's not forget the moons of Jupiter and Saturn. Europa, for example, may have an ocean beneath its icy surface, but getting to it is a whole other challenge. Not only do we have to get through kilometers of ice, but we also have to contend with the radiation from Jupiter's powerful magnetic field. These places may hold great potential, but they also come with unique dangers and obstacles that we haven't fully figured out how to overcome yet. Despite these massive challenges, the human drive to explore and expand is relentless. Even as we face setbacks, the dream of terraforming is pushing us forward. And who knows? Maybe we'll discover new technologies, new methods, and new breakthroughs that will help us overcome these obstacles faster than we ever thought possible. The truth is, while terraforming is a monumental challenge, it's not something that's entirely out of reach. It's a test of humanity's ingenuity, resourcefulness, and ability to think long-term. It's going to take every ounce of our creativity and willpower to make it happen. The biggest challenge of terraforming is not just the technical aspects, it's the sheer scale of what we're attempting. A planet is not a project you can finish in a few years. It's a century-long journey. But that's exactly what makes it so exciting. We're not just trying to survive, we're trying to create a new home, a new future, and a new Earth. Alright, so we've covered the science and technology behind terraforming, and it all sounds pretty incredible, right? I mean, creating a new Earth, turning barren worlds into thriving ecosystems, it's like something straight out of science fiction. But here's the big question, should we be doing this at all? What's the ethical side of terraforming? Now, we're used to thinking about terraforming as a solution to humanity's problems, like overpopulation, climate change, or the depletion of natural resources. But there are some pretty big moral questions that come with reshaping entire planets. For one, is it right for us to alter worlds that may have their own ecosystems, even if... Let's take Mars, for example. While we don't have proof of any complex life on Mars, there's always the possibility that microbial life exists beneath the surface. If we start terraforming Mars, are we taking away the chance for that life to evolve naturally? Could we be wiping out something that's been developing for millions of years? And if we do find evidence of life on other planets or moons, how will we handle that? These are tough questions. If we start altering a planet, we might be disrupting natural processes that could have their own value, even if we don't fully understand them yet. But on the other hand, are we obligated to give planets like Mars a chance to become more Earth-like to make them places where humans, or other life, could thrive? After all, who decides what is worth saving or transforming? And there's another issue to consider. What if we terraform a planet and it ends up being a failure? What if, in the process of trying to make a planet habitable, we make things worse? Maybe we're introducing new chemicals or organisms that we don't fully understand, and suddenly the environment goes haywire. This is a huge gamble. We're not just playing with land or resources, we're playing with entire ecosystems that could take centuries to rebuild, if we even can. Here's the thing. Once you start changing a planet, you can't just undo it. There's no reset button. Terraforming involves irreversible changes that could have unintended consequences, not just for the planet, but for the people living on it as well. So, should we be messing with planets in the first place, knowing how risky it is? Then, there's the whole issue of human greed and responsibility. Let's be real. There's a lot of money and power tied up in space colonization and terraforming. The more planets we can turn into habitable zones, the more resources, space, and living areas we have for future generations. But that raises another question. Are we doing this because it's the right thing for humanity, or because it benefits the people who have the resources to make it happen? And what about the potential for terraforming to become a shortcut to fixing Earth's problems? Let's say we start terraforming Mars or another world while Earth continues to struggle with pollution, climate change, and resource depletion. Are we just escaping our problems instead of fixing them here at home? Shouldn't we be working harder to solve Earth's issues before we start remaking other planets? On the flip side, it could be argued that terraforming is a way for humanity to preserve itself, to ensure that we have a future beyond the confines of Earth. With all the challenges we face on our home planet, maybe expanding to other worlds is exactly what we need to ensure survival. After all, if something were to happen to Earth, like a natural disaster, a war, or a catastrophic environmental change, it's good to have a backup plan, right? It's about survival, but it's also about expanding human potential. Our capacity to thrive and create new worlds where future generations can live. If we can terraform a planet, we can show that humanity is capable of unimaginable feats of innovation and adaptation. It's a testament to our desire to push the boundaries of what's possible. And here's the kicker. Terraforming doesn't just affect us today. It will affect generations far beyond us. The choices we make now, about how and why we terraform, will shape the future for centuries. It's not just a project for our lifetime. It's a legacy. People will look back on this time in history and ask, why did we do it? What were we thinking? Did we do the right thing? And maybe, just maybe, the answer is more complicated than we could ever imagine. Okay, so we've talked about the challenges and the ethical dilemmas. Now let's dive into the real fun stuff, the technology. How exactly do we plan to terraform a planet? Well, it turns out, the future of terraforming isn't just about building fancy domes or sending a bunch of astronauts to plant some trees. We're talking about some seriously advanced tech that could change the game completely. First off, let's talk about the atmosphere. One of the most important things to consider when terraforming is creating an atmosphere that can support life. Take Mars, for instance. It doesn't have the thick atmosphere we need for human life. What we need is a way to thicken the atmosphere, to trap more heat and get it to the point where liquid water can exist on the surface. Enter greenhouse gases. We could use giant machines to pump out gases like carbon dioxide or methane, which trap heat in the atmosphere, creating a greenhouse effect. This process, called atmospheric warming, would slowly raise the temperature on the planet, making it more Earth-like. It's kind of like giving the planet a warm blanket. Another tool in the arsenal is space mirrors. Sounds like science fiction, right? But actually, scientists are seriously considering using large reflective mirrors in space to direct sunlight onto the surface of a planet. This extra sunlight would help heat the planet, especially in the early stages of terraforming when we need to raise temperatures significantly. These mirrors wouldn't just be used for heating, they could also help by providing light in places where the planet might not get enough natural sunlight. Think of them as giant solar panels in space, but instead of generating power, they're generating the conditions needed for life. Water is, of course, a huge factor when it comes to making a planet habitable. You can't have life without it. On Mars, there's evidence of water in the form of ice buried beneath the surface. But how do we access it? That's where advanced drilling technologies come into play. Scientists are designing robotic drills capable of breaking through layers of ice and rock to extract that water. Once we extract the water, we could either release it directly into the atmosphere or use it to create lakes and rivers. This is one of the most complicated parts of terraforming, because it's not just about water supply, it's about creating the right balance of water vapor in the air to help build a breathable atmosphere. The goal is to create a perfect water cycle, just like Earth's. But here's something that's truly mind-blowing: genetically engineered organisms. In the early stages of terraforming, we might need to jumpstart the atmosphere with oxygen, and one of the best ways to do that is by using plants. But not just any plants. Plants that have been genetically modified to thrive in harsh conditions. These plants would be able to survive in environments that are, frankly, inhospitable to life as we know it. They generate oxygen through photosynthesis, slowly making the air breathable for humans and other life forms. Think of them as terraforming plants, the first real step towards turning a barren planet into something lush and life-supporting. And while these plants are busy making oxygen, other technologies are at work too. In order to create an Earth-like climate, we'll need to consider controlling the temperature, humidity, and even the seasons. A big part of that is going to involve using advanced weather control systems, machines that can regulate cloud cover, rainfall, and even temperature to simulate Earth's natural weather patterns. It's like we're building the weather from scratch. The goal here is to create a stable and balanced environment, not just throw a bunch of water and heat at a planet and hope for the best. We'll need to carefully monitor and adjust these systems to ensure everything stays in harmony. Of course, powering all of this terraforming technology is a challenge in itself. Fortunately, we've got the technology to harness energy from the stars. Solar power is going to play a huge role in terraforming. With solar panels that are far more efficient than anything we've got today, we'll be able to harvest massive amounts of energy, not just to power the machines we need, but also to keep the lights on for future colonies. Solar panels in space could beam energy directly to a planet, helping terraform it without relying on Earth-based resources. This would give us an almost unlimited supply of power for all the machines and technologies needed to reshape a world. Then, we've got the transportation and logistics side of things. You can't terraform a planet if you can't get all your tools, materials, and people there in the first place, right? That's where next-generation spacecraft come into play. These will be capable of transporting large payloads, entire construction crews, and huge amounts of equipment across the vast distances of space. Spacecraft capable of carrying everything needed for large-scale terraforming missions will be crucial. These ships will not just be transport vessels, they'll be mobile terraforming hubs, equipped with everything from advanced machines to research labs, and even biodomes where we can test life support systems before we bring them to the surface of the planet. As you can see, terraforming isn't just about one or two technologies. It's a massive, interconnected effort that will rely on everything from advanced engineering to biology to space exploration. We're going to need to pull from every corner of human knowledge to make this happen. Alright, so let's get real for a moment. We've talked about the science, the tech, and the ethics. But there's one question that always comes up when we discuss terraforming, and that's, how long is this actually going to take? I mean, if we're talking about turning Mars into a new Earth, it's not like we can snap our fingers and, boom, greenery everywhere. So, how long are we looking at for this to happen? Here's the thing. Terraforming is no short-term project. We're talking about decades, even centuries of work to get a planet to the point where it's habitable for humans. Depending on the planet and the methods we use, it could take anywhere from a few hundred years to thousands of years to terraform a planet. Let's break this down. For Mars, which is one of the prime candidates for terraforming, scientists estimate it could take anywhere from 100 to 1,000 years to make it fully habitable. And that's with all the fancy technologies we've been talking about: space mirrors, greenhouse gases, water extraction. But remember, this process isn't like flipping a switch. It's going to take time for each stage to unfold. The first step? Heating up the planet. We need to raise the temperature enough to allow liquid water to exist and to start forming a breathable atmosphere. That could take anywhere from 50 to 100 years. Even with all the solar mirrors, carbon dioxide machines, and other tech, it's not going to be a quick fix. We're talking decades of slowly building up the atmosphere to the point where things can start growing. Once we've got that base temperature right, then we need to focus on water. If there's no liquid water, there's no life. That's where the real work comes in. Unlocking water from underground ice reserves, or even bringing it in from other places like moons or asteroids. This could take another 50 to 100 years. It's not like we're just going to flood the planet overnight. We need to gradually create lakes, rivers, and oceans, all while making sure the atmosphere can handle it. Then after all that, we need to introduce life. And not just any life, plants that can survive harsh conditions, genetically engineered plants that can thrive in low light, extreme temperatures, and low oxygen. Once these plants start photosynthesizing, they'll help produce oxygen, which is critical for making the atmosphere breathable. But that could take another 50 to 100 years, just to get things started. After that, well, once plants are in place, it's about building a full ecosystem, one that includes animals, insects, and a self-sustaining food chain. That's where things get complicated. If we try to rush it, we could risk throwing the ecosystem out of balance, creating problems that could take centuries to fix. By now, we're looking at 100 years or more to develop a sustainable system of life. It's not like planting a few trees in your backyard and watching them grow. We need to carefully manage the ecosystem, adding new species and ensuring everything works together to create a balanced environment. And here's the tricky part: human habitation. We might have a breathable atmosphere, plants, and water, but that doesn't mean humans can just walk out into the open. Even after a few hundred years of terraforming, we'll probably still need biodomes or protective gear while the planet's ecosystem stabilizes. It could take another 200 years before humans can live freely without some kind of protective gear or environmental suits. Remember, while we've been working on terraforming, nature is still taking its time. Once we've set everything in motion, we can't just sit back and wait for everything to happen. Terraforming is going to be a slow and ongoing process. Even after we've made the first breakthroughs, it'll take centuries of careful monitoring and adjustments. We're not going to get everything perfect right away. Even after centuries of work, there will still be challenges. We'll need to keep adjusting things, fixing problems as they come up. There will be setbacks and there will be breakthroughs. Terraforming is a long-term investment in humanity's future, one that requires patience and perseverance. So, to answer the question, how long will it take? At least 300 years, possibly more, before we can truly call a planet like Mars home. But with every generation, we'll see progress, and each step will bring us closer to making these worlds livable. The truth is, this is a multi-generational effort, one that's going to take far longer than any one person's lifetime. Now that we've covered the science, the technology, and the timeline, let's zoom out a little and think bigger. What's the ultimate goal of terraforming? Well, in a word, colonization. We're not just talking about making a planet habitable for a few researchers or pioneers. We're talking about creating entire, thriving human civilizations on planets that were once cold, barren. Terraforming isn't just about turning Mars or any other planet into another Earth. It's about opening up the cosmos to human civilization. Imagine hundreds of years from now, where we're not just stuck here on Earth, but thriving across multiple planets in our solar system, and even beyond. It's a vision that's both exhilarating and overwhelming, but it's also increasingly within the realm of possibility. Let's take Mars as an example. Once we've turned it into a habitable world, the next step would be to build self-sustaining colonies, cities, farms, factories, even schools and hospitals. But that's not where it ends. We're talking about a new frontier for humanity, one where space exploration, scientific discovery, and human innovation will go hand in hand. These colonies would eventually be able to support millions, if not billions of people. Over time, we might see an explosion of new colonies popping up not just on Mars, but on other planets or moons in our solar system. Take Europa, one of Jupiter's moons. If we could terraform it, it could become a hub for scientific research and even space tourism. Or think about Titan, Saturn's largest moon. With its thick atmosphere and the possibility of liquid methane lakes, it could offer an entirely new kind of environment for human life. As we start to colonize these new worlds, the concept of space travel will change dramatically. The technology we develop for terraforming will also make interplanetary travel faster and more efficient. No longer will it take months or years to reach a new world. Instead, spacecraft will be able to travel regularly between Earth, Mars, and other colonies, creating a bustling network of human activity in the solar system. The whole idea of space colonies is not just about living on other planets for the sake of exploration. It's about ensuring the survival of humanity. The more we spread out across the solar system, the less vulnerable we become. If something were to happen to Earth, whether it's an asteroid impact, a natural disaster, or even a human-made catastrophe, we'd have backup colonies where human civilization could continue. This isn't some far-off dream. Space agencies, private companies, and even international coalitions are already working on the technologies that will make this possible. Musk's SpaceX is pushing for human settlements on Mars, while NASA is actively developing ways to send humans to the moon and beyond. The momentum is building, and while we're still in the early stages, the progress is undeniable. By the time we've completed terraforming efforts, it's likely that we'll have advanced genetic engineering, artificial intelligence, and robotics all working together to support life in these new environments. Robots could assist with construction, farming, and even the delicate job of maintaining the terraforming process itself. These robots will play a critical role in ensuring that everything stays on track. Let's not forget about the social and cultural impact of colonizing new worlds. Living on a new planet isn't just about survival, it's about building new societies. With so much distance between Earth and these new colonies, each one will have to establish its own systems of government, economy, and culture. Imagine how different these societies might look. More open to new ideas, with unique customs and ways of life that are shaped by the environment they live in. In a sense, these new colonies will be like the pioneers of old. Just like the early settlers who left Earth to explore new lands, these new space pioneers will shape the future of humanity in ways we can't yet fully understand. They'll be the ones to adapt to the challenges of living on another planet, and in doing so, they'll pave the way for future generations. Once terraforming is complete, life on Mars, or on any other terraformed world, will be completely different from what we know on Earth. We're talking about a totally new way of living, where technology, nature, and human ingenuity come together in ways that seem unimaginable today. And, just like Earth, these new worlds will eventually develop their own histories. They'll have their own challenges, victories, and unique stories. And who knows, 100 or 1,000 years from now, we might be looking back at our first attempts to terraform and colonize,